Hi, everyone. Thanks so much for joining us tonight. We're really excited to have you all here for our third of three workshops for the Electrify Everything Minnesota residential workshop series. My name is Kayla. I'm the city's sustainability coordinator. I'm here with my team. Sarah and Nolan are also part of the sustainability team. And then we're here today with our partners at the Center for Energy and Environment to talk to you about all things hot stuff. So water heating, cooking, and clothes drying, and ways that you can improve the efficiency and start to decarbonize or remove fossil fuels and convert to electric appliances. This workshop series is brought to you through a grant through the Department of Energy, the Energy Efficiency and Conservation Block Grant, which allowed us to put on this workshop series. So thank you to the DOE. And we also have, let's see, through this work through Electrify Everything this year, we also have done some home builder education. So for those that are building homes in Rochester, some education around energy codes, and then also education for actual installers of the equipment to kind of learn about the technologies from the company perspective and things like that. So trying to kind of hit all different pieces of the puzzle when it comes to home electrification. And new news is that we will be doing this workshop series again in the fall. So if you are interested in this information, or if you maybe missed workshop 1 or 2 and you want to come back in the fall, we'll be hosting this again in September, October, and November. Or if you know someone else that might be at the point where they're, interested in this information or kind of ready to learn more about electrification in the fall, feel free to connect them with us, and we'd be happy to share those dates out, and I'm sure we'll share them with all of you when we have those. So thank you all again so much for coming tonight. Feel free to help yourself to sandwiches in the back. We also have some smoothie bowls. So thank you again, and with that, I'll turn it over to Matthew.
Thank you, Kayla. Great to see you all again. See a lot of folks we met at previous workshops, so thanks for coming back. And we are really excited to dive into appliances and electric panels tonight. I'm Matthew Douglas May. I work for the Center for Energy and Environment with my colleagues Sean and Jason here. And we run our Electrify Everything Minnesota program, which is supported by the City of Rochester Destination Medical Center and a number of other local government partners across the state. And the goal of Electrify Everything Minnesota is to support the gradual electrification of residential homes through providing education here tonight, and then resources and one-on-one support to make these upgrades possible and less daunting. So we're here to support you from learning about it to completing these upgrades in your home. So what we're going to talk about tonight is a quick review from workshop 1, the benefits and basics of home electrification. And then we're going to dive into the different appliances. So we'll talk about heat pump water heaters, induction stoves, heat pump clothes dryers, and electrical panels and wiring. And our goal for each of these topics is to give you information you need to make an informed decision for choosing the right version of this for your home, and so that you know what questions to ask contractors or installers, so to make sure you're meeting your goals and what you want out of this upgrade. Then we'll end with some resources that will help you tackle these projects, and then we have a resident panel tonight, which we're really excited about. So we'll have 2 Rochester residents who will share their experience, and you can ask questions of them at the end. So during the presentation, we will pause for clarifying questions, but we ask that you hold kind of like vigorous, substantive questions till the end. We'll answer those at the end, and then also the panel is a great opportunity to ask, like, what's your experience with an induction stove, for example? If you're online, thank you for joining us. Put your questions in the chat, and we will include those in the Q&A sections of tonight. And we will be sending out the slides via email after this workshop with all the links and resources that we mentioned here. So you'll get everything that you see today. So with that, What have we covered in our previous workshops? What are the steps and benefits of home electrification? So why are we talking about home electrification? What's all the hubbub about? And one of the big reasons is that home electrification is the clearest path to decarbonizing or reducing our greenhouse gas emissions in our homes. That's because the electric grid is clean and getting cleaner. And Rochester Public Utilities is actually a leader in this space, and they're on a path to achieving 100% net renewable energy by 2030. So what that means is an appliance installed today, in 5 years, will be using 100% net renewable energy, no greenhouse gas emissions. So that's a really big deal. It means we're tying your home to the electric grid, ties your home to that path. And even with today's fuel mix across Minnesota, over half of our electricity is from carbon-free sources, which means using an electric appliance versus a gas appliance has lower carbon emissions even at that baseline. Another big benefit of home electrification is health improvements. Using electricity is safer because combusting gas in our homes comes with the risk of releasing those pollutants into our home or other hazards. And when we have electric appliances, those risks just don't exist. So switching over to electric can eliminate some of the health risks that come with gas. So when we're talking about home electrification, we aren't, talking about TVs and smaller things. We're talking about the big areas of your home that most commonly use gas. So the 6 key areas are weatherization and heating, which we talked about at our last workshop. And tonight we'll be talking about the other big 4. So that's water heating, clothes drying, cooking, and then electrical panels. And the reason we focus on these areas of the home are, one, because they're the most common areas where we use gas in a home, but they're also the biggest energy users. So if we're thinking about going for reducing your greenhouse gas emissions or getting more efficient appliances to use less energy, focusing on those big users is where you'll have the best impact. So about 72% of our energy goes towards heating in the average Minnesota home. But water heating is the next biggest chunk. So if you're thinking about impact water heating, getting a heat pump water heater can have a big impact. And then everything else is where the other appliances fall. So before we dive into everything, I want to ask you all, what are some of your motivations for switching to electric appliances? You all chose to spend your Thursday night with us. So what brought you here? What are you interested in? What are your motivations?
Climate change.
Climate change? Great. Yeah, reducing your impact on climate change.
Ditto.
Same here. Great. Yeah. What else? Anyone have a water heater that's threatening to die on them or about to break? Old appliances? See some head nods here. All right, cool. Well, we'll have some, we'll be talking a lot about tailoring your motivations to what actions you take. With that, I'm going to pass it over to Sean to talk about water heaters.
Thank you, Matthew. Hi, I'm Sean Rodine, and as you may have guessed, I'm going to talk about heat pump water heaters. So, Matthew already talked about some of the benefits of electrification, and some of those benefits are also present with heat pump water heaters, such as it's electric, they're electric, so fewer emissions, if that's your motivation. No combustion gases in the home, gas water heater. If they're not combusting properly, they could backdraft or leak or emit carbon monoxide in your home. An electric water heater, you don't have that risk. Or a gas leak, that's a possibility as well. This is not really a benefit most people think of, but they have a dehumidifying effect. So we'll talk about how they work, but they can dehumidify spaces. So if you have a basement that's a little humid, You could run this and it can heat your water and dehumidify, that space. And the operating costs, are comparable with other types of water heaters, or you may come out ahead. So how do they work? Last time we talked about how air source heat pumps work and how that technology moves heat instead of creates heat. And how it pulls heat in from the surrounding air, whether that's outside the home or inside the home, to heat your home. So heat pump water heaters function the same way. If you remember last time, I talked about how heat goes to cold and how we use cold refrigerant to attract heat. Same with the heat pump water heaters, only they pump that heat into a tank and they heat your water, and then on the other end, it expels cool, dry air. So graphically, this is what it looks like. Now, there's a lot going on in this graph, so I want you to focus on only one part of it at a time. Focus on the left part, that cylinder, the smaller cylinder. So on that part of the graphic, we have warm air coming in, and that's the top of the heat pump water heater. And if you look inside of it, we have two of our friends from last time. We have our compressor, that smaller cylinder inside, and then we have the expansion valve that either heats the refrigerant or cools it by increasing pressure or releasing it. So what it does is it draws in that warm air, and again, heat goes to cold, so that warm air is coming in, and it's being attracted by that cold refrigerant. It's running through those blue coils, and that's called the evaporator. When that warm air hits that cold refrigerant, that is when it condenses, and then you get the condensate, and that collects, and that's how it dehumidifies. But anyway, when it hits the refrigerant, it picks up that heat, and then it basically changes the temperature of the refrigerant. The refrigerant temperature increases, and then the compressor further increases it by compressing it, turning up the temperature, and then that goes down into the tank. So we'll move over to the right side, the larger graphic. So you can see on the right side, that is your tank. It looks very similar to a traditional water heater. Only you have those coils going around the tank, and that is heating your water. You also notice that there are two electric heating elements. So it isn't just the heat pump that's maybe heating the water in these tanks. You also have resistance elements that if there's times of high demand, or depending on the setting that you put on some of these water heaters, you may engage those elements. So they use both, but you can just use the heat pump setting. We'll talk about settings a bit later. So basically, this is what happens. It draws in the heat, uses the heat pump technology to heat the water. And then because it's removing heat from that air, cool air is coming out the other side. So the cold water goes into the tank and hot water comes out. This is a simplified version, but it drives home the point. So you saw this warm air going in, cool air going out. You might have this question on your mind. Will I run out of hot water with a heat pump water heater? Because you see, okay, this technology, fine. Maybe it works, but my main concern is being mid-shower, covered in suds, and all of a sudden runs cold and to wait for the water to heat up again. And no one wants to do that. So will you run out of hot water? So this is how hot water heaters, heat pump water heaters compare. And we talk about the recovery rates. And I think there are a few lines here, but maybe the easiest one to focus on is that top one. We can think of it in terms of showers. So how many consecutive showers can a heat pump water heater deliver? And when we look at them compared to a gas tank or ER's electric resistance, they're pretty comparable. You could probably get away with about a little over 3 consecutive showers before your water runs cold. But that's about the same, maybe a little bit more in a gas tank, get a quarter of a shower more, half of a shower. But it's comparable to electric resistance. They are much more efficient because, as I said, they are moving heat from your air to the tank rather than creating it, combusting a gas, or just firing up those electric resistance elements. And you'll notice the first hour rating, which is the number of gallons of hot water delivered in the first hour. How many of you run that within the first hour can you deliver? 66, 67 gallons comparable. I will say the recovery rate, which is how much you can heat the water by 90 degrees in an hour, is lower. The gas, just combusting a gas, will do that quicker. But the heat pump water heater will do that. Will heat more gallons of water than the electric resistance water heater. So pretty comparable in many ways. I will also mention that this is a larger heat pump water heater than the two. It's a 40 gallon gas tank in electric resistance and a 50 gallon heat pump water heater. We'll talk about size and why that matters quite a bit. Segue. Okay, getting the sizing right. So again, you don't want to run out of hot water mid-shower or anytime really. So what's about the right size for the right number of occupants? So a 50 gallon tank is good for about 1 to 2, maybe 3. If you have maybe a small child, who doesn't use a lot of hot water, take long showers. So 50 gallons might do. 65 for 2 to 4 occupants. And then with 3 to 6, that's a big range, but 80 gallons is probably the right size. Again, this depends on your water consumption habits. And, you know, if you wash all of your clothes or a lot of your clothes with hot water, maybe you don't want many of them or any of them at all with hot water, that can influence it. Also, if you have teenagers or children who are less mindful, that could also influence it as well. Which is why you might want to consider going up a size. So we recommend going up a size from your current hot water heater when you are going from gas to heat pump water heater, which is why the comparison showed a larger unit than the electric resistance and gas. If you have a house that includes children or teenagers who are generally less mindful about getting in and out of the shower, you know, sometimes in there for a long time, you might want to go up a size so you don't run out of hot water. Or if your occupancy is likely to change within the next 5 years. So maybe you're expecting a new member of the family or someone to move in with you for the next 5 years. These have a lifespan of about 15 years. So if you anticipate that, you might want to go up a size. Another solution for creating additional hot water is using what's called a thermostatic mixing valve or a tempering valve. And what that does is that tempers the amount of cold water that is mixed in with the outgoing hot water. So what you can do is you can turn up your temperature on your heat pump water heater to 140 degrees as opposed to about 120. And the water will be warmer, and then you mix in more cold water when it goes out, and thereby you kind of increase the size of your tank by increasing the temperature. You don't really increase the size of it, but the temperature is going up so that you'll have more hot water going out. Now, if you increase the temperature, your bill may be higher, but you won't run out of hot water. So you'll be less likely to. So that's a trade-off that you have to account for. But that's one way of kind of expanding the size of the tank is by incorporating one of those. And those cost roughly, I saw a figure like $350 parts and labor to install. So that's another factor to weigh. Some other options are 120 volt models. So they're pretty widely available now. They were new recently, but this stuff's moving pretty quickly with advances in technology. So 120 volt models are a great option for smaller households. And generally, 120 volt models, you wanna go up the size, regardless. But, they're also really good for homes that would otherwise need an electric panel upgrade, and Jason will be talking about that. If you wanna avoid that, if you wanna limit the amperage on your panel, you could go with a 120 volt model and, kind of, mitigate that. So this is a good option. And again, upsizing or heating up to 140 degrees, and then using that thermostatic mixing valve is another solution for increasing your capacity with one of these models.
How many gallons?
How many gallons is this?
Well, you got two different ones there.
Yeah, I'm not sure. One's a little taller. It's probably 50 and 65. I assume. Okay, so getting the sizing right, we talked about sizing and what you might want to consider. You may not be asking this question, but the location where you put these things is pretty important. So where should you have your heat pump water heater installed? Location, location, location. The location of your heat pump water heater is very important for a few reasons. And that has to do with air volume, comfort, and maintenance. So location and air volume, these things, as we saw in the diagram, they're bringing in air, right? And then they're expelling air. So if they don't have a proper amount of air volume, it's kind of like they're trying to draw in air and they can't, or expel the air. And the same, if it's they're in a very small space, it doesn't work very efficiently. It can affect the efficiency of the units. So they need an adequate amount of air volume to function properly. And what they recommend is usually between 450 and 700 cubic feet for rooms such as basements and utility rooms. And this room is about 450 cubic feet, but you can, do length times width times height and figure out what you might need or what your basement might be able to provide, or the room where your water heater is currently in. There is an exception or a caveat. Your rooms can be smaller if they have what's called a louvered door. So louver is these doors that have these grates or these slits in them, or the unit is set up to be ducted. So what this does is it allows air to pass. Again, we're seeing air coming in to the heat pump water heater and going out, and allows for that free flow of air. So this is a louvered door with grates on the top and the bottom, and warm air being drawn into the top, and then the cold air falls and goes out, and you have this loop of air. These need to be installed inside Minnesota. In the south, they can put them in garages and get away with that because it stays warm enough. But if you install them in a garage here, it's gonna have a hard time heating that cold air and getting it up to 140 degrees. So they need to be installed inside, and you should not duct these from or to the outside because of the great temperature variation. So I'm not going to talk about ducting that much. That's kind of for a technician, or that when you get these, the manuals have ducting guidelines, but you should duct from in to outside, so that you have the temperature, it stays at a temperature where the water heater can function efficiently. Okay, maintenance. One thing to know about these is because they have that heat pump water heater, or they have that heat pump on top of them, they are taller than normal or traditional water heaters. So they're about 5-6 feet tall, 75 inches, that's 6'3". That's pretty tall. And the filters are generally located on top of the water heater or near the top. So if you have a low basement, you want to watch your clearance, because making sure that filter is clean is an important part of maintenance, so that air can flow freely through your water heater. So make sure there's about 6 inches or more of clearance wherever you're going to choose to install these.
Those like a throwaway filter version.
No, I don't believe they are, but I think you clean them off. wash them off.
If you have regular water here, you can't turn it into a heat pump water, you can make. But you can with boiler.
You can integrate, with a furnace, you can integrate a heat pump system, with some of them, it depends. Depends on your system. With a boiler, no, you can't integrate. You have to use like mini splits. With this one, you'd have to replace the whole thing, yeah.
How frequently are you supposed to look at that to see if you need to clean it?
That's a good question. Not sure.
Okay.
Do you know, Matthew?
They recommend every month, once a month.
We had one for a year and I never, when the person put it in, I never heard about this.
But that's usually what we hear, but they don't get cleaned that often, but every month.
Easy to forget. Okay. So. Another question that may have occurred to you from that diagram is if my heat pump water heater removes the heat from the air, will it leave my house feeling cold? What we've observed and what we've read and what technicians have told us is that it changes the temperature, the ambient temperature of the room about 1 to 2 degrees during the heating months. Now, if you put a thermometer right next to that cold air coming out, it's probably cooler than 1 to 2 degrees of the ambient temperature, but if this is in a room, 700 cubic feet, it's gonna regulate, it's gonna moderate, but you may notice a small difference in the temperature in the room. These are only felt when the unit is running, and that's on average about 3 to 5 hours a day. So let's say family gets up in the morning, people shower, get ready for work or school or whatever you have. Go out the door, that heat pump water heater is gonna start running, gonna start reheating, recovering, charging that water. And that'll only be about 3 to 5 hours a day. Depends when you use your hot water, but it's not gonna be running constantly, day and night, to keep that water warm. This temperature difference is generally not noticeable if it's installed in a basement or utility room, or a place that you don't really occupy that much. But you wanna make sure that you don't install this near the outgoing air, near somewhere that's frequently occupied. Like where someone might sit and read or watch TV or something like that, cause yeah, you'll notice there's cool air. It'll feel like maybe a bit like a draft. We usually avoid those.
On this picture, would you show me where the filter is? Because it looks like it's at the top. There's all kinds of things coming down into the top. How would you remove that to get a filter?
I'm not sure on this unit. I'd have to look at it. Matthew, you actually, you saw this in
I've been in
person.
this basement, so that silver pipe that's on top of it, it's actually like behind it, so the filter is accessible from
Okay,
the
so
top.
nothing's coming down into the top.
Yeah, you would just kind of pull the filter, if this is the top, just pull the filter up, and there's space, yeah.
Thank you.
So there's like a lid on it?
It's like a vertical sheet that just sticks down into the heat pump component there.
piece of toast.
But there's a cover.
Okay.
So it's like,
Yeah, a piece of toast is a great.
that's approximately what height? 6'3", like the one on the fence.
Yeah, I was just about as
How
tall.
much above it do you need besides the 6 feet? And like.
The question was how much space you need above the water heater, and yeah, as Sean mentioned, like 6 to 12 inches.
12 inches long.
Yeah, well, this one looks like they have good clearance. You'll also notice underneath, they put something, and made it a little bit taller. We'll talk about why that is. A little platform for a cushion there.
Does it hurt to be on a cement floor?
We'll talk about that
Oh.
very briefly. So you may have heard that, heat pump water heaters make noise or more noise than traditional water heaters. So how much noise do they make? I'll tell you that they do make noise and more noise than traditional water heaters. The newer models make around 45, 52 decibels on average. some of the older ones, I say older, I mean like 2 or 3 years ago. They may make between 60 and 70 decibels. So you'll see, people, taking decibel readings of their heat pump water heaters on average. But I mean, when I tell you that, unless you're a sound technician or work in the field, you may say, "Oh, I don't even know how loud that is." Well, it's about what a dishwasher makes. Or we have this rainbow scale, an urban residence, or a conversation from 3 feet away, around there. But again, this only happens about 3 to 5 hours a day, so it's not gonna be, like a dishwasher running. I mean, unless it's recovering during the evening, you shouldn't hear it around then. And a lot of people get used to the sound and you kind of just tune it out. Kind of like your dishwasher, but you're really focused on it. But this is another reason why location is important. Putting this in the room that's next to the head of your bed. Probably not a good idea. I mean, could do it, but if you want to take an afternoon nap, that thing's recovering. May bug you a little bit. You can also mitigate noise, by choosing the right location. First of all, for installation. This photo, they just have this closet where, I don't know how many options they had for installation, but this was probably the best one. So they use these small rubber pads, because it's probably gonna fit in there pretty snugly against the wall because it has a compressor, so it's gonna be compressing and like vibrating a little bit. So these rubber pads can mitigate the noise. And then you'll notice, also on the bottom, I don't know if that's a rubber pad, but they put something underneath so they wouldn't be sitting on the floor. I had a question about cement floor. That basement before had a cement floor, right, Matthew? So, but they put something underneath to cushion that. So again, the sound would be mitigated, the effects of that. So yeah, it's important to think about where you're installing these and then what you can do if you need to do anything to mitigate the noise that it will make. Questions for contractors. So asking the right questions of these contractors, will help you find the right heat pump water heater for your home. And you may have guessed, but the questions that you should ask should address or should have to do with sizing and location. So if I were speaking to a contractor, I would ask them how they would be determining the size for my household. So a contractor should ask how many occupants are in the household typically. Maybe you have someone who comes and stays with you and leaves, or you Airbnb, or who knows, grandkids. So they should ask that so they know how to size properly. Are there any issues with your hot water supply now? Are you having problems? Is it supplying just fine? They may say, well, you should size up if you sometimes run out of hot water. They should ask about your water usage patterns, or they may ask about your water usage patterns, just in case that's relevant. And maybe they would propose sizing up, especially in the cases where we mentioned you're switching from gas to heat pump water heater. Yeah.
So we want to do a 40-gallon. And everybody we talk to says that's too small. And we know what our water usage is and what our hot water usage is, and they just keep arguing about it. And it's like saying that you need to buy a bigger house when you know you don't need a bigger house.
Right. Yeah, well, I think that's you hold that question for the panel. If they have experience talking to contractors, I think that'd be an excellent question. But yeah, you don't wanna buy in excess, right? Yeah. A contractor should not just say they'll do a 1-for-1 size replacement. Because again, all these factors may affect the size that you actually need. Okay, how do you determine where to install this? So the contractor should do all these things that I talked about, the air volume requirements. This is also in the manuals, they tell you about the air volume requirements and the options for ducting or the louver doors. They should look at the location of the current water heater and see whether it would be appropriate for a heat pump water heater. Maybe there's a better location, maybe not. ask about frequency of certain locations and whether, if there is cool air coming out, whether that would affect comfort. And then describe how location can affect that comfort, so. If that's the case, so if it's in the basement, you only go down there once in a while, maybe it won't affect your comfort too much. They shouldn't just say they'll put it where the old one is, because again, this is different technology and, that's just, it may not work, or maybe it would, no. Post installation, once installed, please ask your installer to walk you through the operational modes. And, we had your example, show you how to find and remove the filter. So that, you know where it is, you know how to take it out, and how to take care of that unit. So that's important for its efficiency. And because, the operational modes can vary by brand, ask them to walk you through it. These are 3 different heat pump water heaters, A.O. Smith, Rheem, and Bradford White. And when the compressor or the heat pump is only operating, A.O. Smith calls that efficiency, while Rheem and Bradford White call that heat pump mode. However, when the electric elements are engaged, A.O. Smith calls that hybrid mode. Rheem calls it energy saver, maybe using more energy. And Bradford White calls it hybrid. So you may not know on the face what these mean for that particular brand. So ask the technician to say, hey, could you show me what means what? We have heat pump water heater installer network with experienced contractors. This was created by Electrify Everything Minnesota, and these contractors completed training and they verify their experience and their credentials. So this would be a good place to start if you're looking for a technician or an installer who has experience and knowledge about this technology. But these questions I just mentioned would be good for any contractor to ask them to see, to vet. Make sure that, you know, they know they know the technology well. Okay. The $1 million, well, it's not a $1 million question, but it is, has to do with money. Do heat pump water heaters save money and or energy? So this is gonna depend upon what you look at. Are you looking at the energy guide sticker on the side of the water heater? Are you looking at the electric resistance water heater? Sorry, are you looking at the calculators? Are you comparing it to electric resistance to gas tanked, gas tankless? These are gonna say different things and measure different things. So the energy guide, this yellow sticker that you'll see, the heat pump water heater comes out favorably against most of the models. Again, this could depend on the size. You may have to go up a size, or you may stick with the same size. But with the electric resistance, it comes out pretty favorably. Your operational costs are going to be much lower with the heat pump water heater. That's the top. The top one, so 419 compared to the 3 on the right, are all heat pump water heaters. The bottom one, that's gas. Bottom left, you save about $181 per year. That's a gas tank, and then the one on the right is tankless, $55 per year. So it depends. These are operating costs. If you look at this is the Rocky Mountain Institute's green upgrade calculator, and this is compared over 15 years, the life of the water heater. And this has the heat pump water heater coming out to be about over 15 years, about $860 more expensive than the natural gas tank water heater. Now, I made these estimates, and this is if you size up. So the sizing up is going to be more expensive. So that's one factor. And then this is, of course, estimates based on what's the future, what are electricity prices? How much are they gonna go up? How much is gas gonna go up in the future? A lot of assumptions here that we don't always know. But there's a link to the calculator and you can take a look at that and play with it and put in your own variables if you want. But as far as lifetime CO2 emissions, the heat pump water heater comes out pretty far ahead. And you can see that with RPUs, that top line is the gas water heater. The bottom teal line is the heat pump water heater. if RPU, most of your utilities, I suspect, did not decarbonize the grid in 2030, so you can see that line flattening out. In, what is that, year 5, year 4? So, that's huge, and those are big. I mean, 25 megatons of CO2 equivalent compared to 95, that's a big difference. So big carbon savings for those of you whose motivations environmental. And for incentives, so the typical upfront cost for these is around $4,000 to $6,500. RPUs for the smaller heat pump water heaters has a larger rebate. I'm not sure why, but it's $400 for 20 to 55 gallons. And then if you get a bigger one, it's $90. People's has a $300 rebate. The big thing to look at here is that tax credit, which is up to $2,000. I mean, that's a pretty good chunk out of 4,000. And then the federal Inflation Reduction Act rebates that we're expecting in 2025 sometime, up to 1,750. Again, that's, I mean, 1,750 and 2,000, that's quite a bit of money, so.
But for the one that's expected in 2025. In Minnesota, that we're still waiting, right?
Well, you're gonna wait for the big vehicle. It's all gone.
Yeah, we're still waiting for them, but keep hearing they're on the way, and we're expecting them later this year. So, late summer.
They
Yeah,
said that last year was in 2024.
I think up to 150% AMI, it's half of that, around 850, but that's still pretty, 850 and 2,000. That's pretty good. Okay. Yes, another question.
Secondary heat source for, I mean, again, do you have to have a secondary similar to a heat pump that's heating the house?
No,
The hot water heater, what, automatically goes over to electricity when it can't pull enough?
yeah, from the heat pump, if it needs, okay, there's a high demand, it has those elements.
And so how effective are those in this part of the country versus?
I mean, the heat pumps are. These are more efficient in. Because of climate in the south, the southern part of the United States, but it's not substantially less efficient in the north. Because generally you're pulling in air from inside, which is 60 some degrees, and then. Depends on your house. And the season, yeah. But anyway, pass off to Matthew.
Thank you. Yeah, since they're installed inside your home, if it's between like a 40 and 90-degree temperature range, they still operate very efficiently. So,
If you go on vacation or you travel, you're gone for a month or whatever, can you turn them off? So that they're not heating, like, you don't.
yeah, they
turn
have
off your
vacation mode.
gas.
Yeah, they have vacation mode and it pretty much turns off, yeah. And you can program them to turn back on before you get home, so they're pretty smart. Yeah, cool, we'll have a lot more time for heat pump water heater questions in the panel. But wanna make sure we have time to talk about our stoves and dryers and electrical panels. So, quick question, who here has an induction stove in their house? Okay, see one there. What's your experience with this, Ben? Great, cool. All right, so starting with induction ranges. There are a lot of benefits to induction cooking, and a big one is that they are safer for children and pets because they heat up the pan directly rather than the surface. So you can actually touch right next to a induction stove that's on. If you're not touching the pan itself or the glass that's touching the pan, you won't get burnt. They boil water super quickly in about 2 minutes compared to about 7 minutes for a gas stove. And they also have really precise temperature control, so you can turn it up and down instantaneously. So folks who are really into cooking and want precise control over their cooking, they find induction stoves are just as good, if not better, than gas stoves. They're really easy to clean and they reduce indoor air pollution that comes from combusting gas in your house. Induction ranges are great. They're a really great option for all these reasons. But for cooking, traditional electric ranges are also a good option. You get those health benefits, and they come at a wider variety of price points. So compared to gas stoves, electric induction or traditional electric reduces the risk of the combustion gases. So gas stoves release hazardous pollutants such as nitrogen dioxide and carbon monoxide when they're on, and even sometimes when they're off due to leaky valves. So that's gas that's leaking in your home and in our common spaces where we gather. And many studies have shown that children who grow up in homes with gas stoves have a higher likelihood to have childhood asthma. So electric cooking reduces those risks completely, and we can cook with more peace of mind. So how do induction stoves work? The short answer is they use an electromagnetic field to heat the pan directly. So there are coils underneath the glass that create an electromagnetic field, and then it heats the pan. And because they use electromagnetics, the cookware must be magnetic. So this is the big thing to anticipate if you're upgrading to an induction stove is some of your cookware may not work, but some of it probably will work. So steel, cast iron, and enamel cast iron are all induction compatible. But aluminum and copper cookware is not compatible. A way you can test this is you use a magnet and stick it to the bottom of your pan, and if it sticks, it's induction compatible. Or you see the symbol in the picture here, if that's on the bottom of the pan, that means it's induction compatible. Something to note is that for people with pacemakers, the electromagnetic field can be a risk. So it's important to check in with a doctor if you have one of these before getting an induction stove. Another thing we've heard is the fast heating can actually take some time getting used to. It heats up so fast that it might burn things that you would expect to just heat up slowly with your current stove. So that ends up being a net positive because you get more control. But if you burn your eggs the first time you use one of these, you'll just have to dial it in. And then they require a 240 volt outlet. So if you don't have one of those in your kitchen, you'll need to run one to that spot, and we'll talk more about that in the next section. The city of Rochester has a really cool lending program where you can borrow an induction cooktop. It's in that box right over there. If you're interested in trying out induction cooking for free, you can check one out tonight. Bring it home, cook on it. They're really fun. So I would suggest, say hi to Sarah and Kayla over there and check out one of them. They come with a few pots and pans and also a magnet where you can test your cookware to see if it's compatible.
Matthew?
Yeah.
I checked one out and I haven't started it yet because I can't quite figure out time. You have to put in a time, not just a temperature. I don't know how much time. I mean, I just know you cook it until it gets to a certain temperature. Like if you're making fudge, it's 230 degrees. How do I know what the?
Yeah, that's a great question. Each of these induction cooktop models have different settings. So let's take a look at the instruction manual together at the end and we can figure that out. Great. Yeah, any other induction cooktop questions? Yeah.
This is a laptop induction stove, right?
Yes.
So how does that compare with the coil top?
Yeah, so the coil top stoves, those are traditional electric resistance. Those heat up that coil and then that heats the pan. So those are a lot slower to heat up and slower to cool down. And they use about 10% more electricity than an induction stove. Yeah. All right. So
So what are you doing about baking?
great question. So we're talking about induction ranges. Those will come with an electric oven. So there are called convection ovens are one option, but it's not an induction oven. It's more of a traditional electric oven. Yeah. All right, so the other appliance in this category is clothes dryers. These are called heat pump or also called ventless clothes dryers. And they come with many benefits as well. They're the most energy efficient clothes drying option out there. If you haven't heard already, we love heat pump technology because it's super energy efficient, and that continues on here. They're gentler on your clothes because they dry your clothes at cooler temperatures, so your clothes last longer. They do not need to be vented to the outdoors, which provides a lot of flexibility on where in your home you can put them. And they're 2 times as efficient as traditional electric dryers. Again, in this category specifically, traditional electric dryers are also a good option if you're interested in something at a lower price point, because dryers don't use as much energy as, say, a water heater or your heating system.
The electric ones though are vented.
Yes, they are, correct. So these heat pump dryers are the only ventless ones.
Why does nobody ever mention hanging their clothes on it? Hey, that's free.
Yeah, I mean, the kilowatt you don't use is the least expensive kilowatt, right?
I mean, it's never, yeah, that.
Yeah, that's a good feedback. So the way these heat pump dryers work is they have little heat pumps in the bottom of them that heat up air, blow it into the drum where the clothes are. That warm air turns the water that is in the clothes into water vapor, and that gets pulled out of the dryer. And then that moist air goes over the evaporator coils, which are cold, and then liquefies or condensates that vapor, and then extracts it through a drain or a pan. So because of, again, the heat pump technology, it's very efficient and quiet. So some things to expect if you switch to a heat pump dryer are that they have slightly longer cycles, drying times. This has gotten a lot better in the last 3 to 5 years. You might have heard someone in like the 90s who had a heat pump dryer that took like 2 or 3 hours. Typically the drying cycles are 45 to 90 minutes for new heat pump dryers, which is about 30-ish minutes longer than your other models. They do not need venting, so you can put them anywhere. Maybe you want to move your laundry from the basement up to the main floor. This could be a great option. You don't have to punch a hole in your wall to vent out. They do require a condensate system. So that's either a pan in the bottom of the unit that you empty after every load, or a drain that just drains automatically. They have multiple filters, usually 2. So 1 more filter to clean, usually not too big of a deal. And again, they require a 240 volt outlet. There are 120 volt models, but they're very small. So a typical family would need a 240 volt option. So for both of these, what should you expect when installing an electric stove or dryer? Like I've mentioned, if you're switching from a gas appliance to an electric appliance, you'll need to be sure that there's a 240 volt outlet near that appliance. So you'll have to, if you don't have that, you'll have to run new wiring, working with an electrician to that area. And you'll need to cap the gas line that was going there for the gas appliance. So typically an electrician, HVAC technician, and or plumber, a mix or one of those can do this work. And that's something to kind of plan ahead on before you get to the store.
Where would you cap the gas line?
Yeah, that's a great question. It really depends on the home, but it can either be, at the location in the kitchen, for example, or if the pipe is, accessible further down the line, they may cap it there, but typically it's where it.
After that, the meter?
The question was, do they cap it at the meter? You wouldn't do that if you have other gas lines in your home. But if you're completely eliminating gas in your home, then you would work with the gas utility to fully cap it and not be a customer of that utility anymore. Yeah. Okay, and then another Another question is, where do I buy one of these? And it's really the same place you go for any other stove or dryer. Typically retailers will sell options for these technologies. So, one thing to look out for is when you go to a traditional retailer, going to one that has lots of heat pump dryer options or lots of induction stove options means you're gonna have more variety to choose from and they're probably more experienced. So that's a good place to start. And it's also, important to note that they may offer installation services, but they may not be able to do new wiring or, have gas lines. Which takes us to our next question. What's the main question you want to ask installers or retailers? And that is, what do your delivery and installation services include? So they should clearly outline that. Do they just drop it at your front door or do they actually install it? Put it, in the place where it needs to go in your home? And do they do wiring and gas tapping or not? So those are two big questions to ask. If the retailer or contractor tries to talk you out of the induction stove you want to get, you might want to try to get a second opinion and talk to someone else. Last but not least, there are a couple incentives available. So for an induction stove, People's Energy has a $25 rebate, and those federal IRA rebates, which are expected later this year, have a pretty substantial income qualified rebate. And then for heat pump clothes dryers, both RPU and People's Energy have a rebate, and there will be a IRA rebate as well. All right, with that, I'm gonna pass it to Jason, and then we will jump into our resident panel to get your questions answered.
Okay, electrical panels and wiring. How many people here are familiar with their electrical panel and where it's at? Most people, okay. So we're gonna talk about some common terms associated with electrical panels and electricity broadly, where we can find them, the function and the components of the electrical panel, how we can go about evaluating our electrical panel, and if we need to upsize it, if we want to plan to electrify our appliances, some of those costs that might be associated with the panel upgrade, and some of the financial incentives that are available to mitigate some of these costs. So how do electrical panels work? We're going to look at some common terms associated with electricity. You may be familiar with these, but amps is one that you hear a lot. It's basically representative of the current and flow of electrons or electricity. Volts represents the force or push on that makes electricity move. And then watts is a unit of power that measures the flow of energy. And here is a graph that's sort of analogizing water with electricity. You can see the flow of water is the current, and so that is measured in amps. Any pressure on that water would be measured as voltage, and the outage or the output is measured in watts. So the electrical panel, most of you obviously are familiar with them. They're going to be a gray steel box in your home that holds circuit breakers. It connects to your utilities energy infrastructure and integrates with your home's electrical system. The breakers in the box itself protects against power surges and allocates electricity to the various circuits throughout your home. And these are just some images of electrical panels. We have one that's actually outside, and then there's a couple other ones. Here's some more images. The panel on the far left is a sub panel. We'll talk a bit more about those later. And then these are your electrical utility meters that are located outside of your home. So since you know where your electrical panel is, you're probably familiar with this, but typically they're located indoors in a dry area, often in a closet or basement, garage. Some locations they can be located outside, but that's kind of atypical for electrical panels. Does anybody know how to find the size of the electrical capacity of their electrical panel? So you find that on the main breaker, and if you've looked at your electrical panel before, it's typically the largest switch towards the top of the panel. It's usually labeled main or service disconnect. And on that, we have images coming up. On that switch, it will typically have the amperage stamped onto the switch, and that's indicative of your panel's capacity. And here are the images I mentioned. So again, at the top of that panel is the main breaker, and you can kind of see on the switch here, there's 200 stamped into the switch. And that's indicative of this electrical panel is a 200 amp panel. So there's various components of electrical panels. Again, the capacity of this panel is 100. You can see it at the top. The capacity is very important when you're thinking about electrifying appliances. You need to know what your current panel's capacity is and what capacity you might need for those electrical appliances that you're thinking about adding. Another important component of electrical panels are the circuit breakers. Probably all familiar with these, especially if you had a circuit break. But these are represented by the gray in this graph here. The circuit panel breakers, there's two different kinds, the single pole breakers, which often work with small appliances, 240 volt double pole breakers work with larger appliances. Breakers are represented with both their amperage and their voltage, and you can see that on the graph as well. For instance, at the bottom, the heat pump that's centrally ducted is a 240 watt device volts, and its amperage is 20. So when do you need a panel upgrade? So there's two things that are determinants if you'll need a panel upgrade. Your electrical space. So we go back here and all these breaker spaces are filled. You may need a panel upgrade. And the physical space, pardon me, the electrical space is the amperage, the electrical capacity of your electrical panel. That's not high enough to accommodate all the appliances you plan to add now, and possibly in the future, you may need to upsize your panel. And what capacity do I need to have for my panel in order to electrify? And so these are some standard panel sizes. We have the 60 amp, kind of uncommon, but you'll definitely need to upsize. 100 amp, a little more common, and it's kind of dependent on what you plan on electrifying in your home, and how many appliances you currently have that you want to electrify. 150 amp, most likely don't need. 200 amp, most likely don't, and it provides a little space for future-proofing your home. So some of the considerations, if you have an older home, you may be required to upgrade the service panel itself. If you have both, this is a picture of knob and tube wiring. If you have something like that in your home, if you have an older home, that's something that would need to be upgraded to modern wiring. And additionally, some other common upgrades are 100 amp to 200 amp service. So these are just some quick facts since we're talking about your panel capacity. And we'll see in the later slide that you can't get away with a lot of electrification with a 100 amp panel. And I'd be interested to see some of the experiences of a resident's panel and see what they came across during their journey. But most medium homes with a 100 amp panel, they only use about 50% of its capacity. So keep that in mind when you're thinking about your electrical panel. The majority of 100 amp homes never exceed that capacity. And but if you do want to upsize from a 100 amp panel to a 200 amp panel, that's going to kind of future-proof your home and make it capable of adding on some future electrification projects if those are something you have in mind. So now, how do we evaluate whether you need a panel upgrade? So these are some things you need to be aware of when you're considering this. You need to understand, as we've gone over, your current amp capacity of your electrical panel. And again, you can find that on that main switch in the panel. It's usually stamped on it. If it's not there, sometimes it can be on the label next to it on the door. If it's not there, you can always look at your electrical utility meter on the outside, and sometimes it will have a stamp on that that will indicate it as well. You need to know how many available circuit breakers you have, if you have any empty slots that you can add additional breakers to, what your current needs are, what they might be in the future, what your long-term plans are for electrifying your home. So there's two main ways you can assess whether or not you need a panel upgrade. The first and the one we suggest, to go with is working with electrician to calculate your electrical panels load. And we'll go through some of the ways that they'll do this. And if you would like to dive into yourself, you can go through some of these options yourself and kind of get a ballpark and understanding of what the capacity of your panel is currently. And maybe if you need to upgrade your panel, if you want to do some future electrification projects. So option one, I'll go over this quickly. Again, you get all these slides, so you don't need to memorize this. But first option, and this is a National Electric Code certified, so it's a way it's a valid way to figure out your panel's capacity. You're basically looking at your annual kilowatt hour usage, doing an equation and figuring out your electrical demand in amps. Another option to assess your panel, and again, this is a National Electric Code as well. And I'll provide links to both of these, so you have them available when I send out the slides. But these sheets are a little more user friendly. You can plug in the numbers. It'll give you a calculation. Electrician will do this same sort of calculation as well. Another option, and this isn't by code, but it's something that'll kind of give you a ballpark idea of what you plan on electrifying and how it may impact your amp usage, your capacity, your energy load throughout the year. This, and I mentioned it before, this is you can get away with a lot with a 100 amp panel. This, I want to caveat it by saying they're in California, so there are some differences between our climate and theirs, but you can see that this is a 4-person home. They have solar, EV charger, induction stove, heat pump, water heater, quite a bit of stuff, and it's all fitting into a 100 amp panel. So there's a variety of ways that you can make that happen. And without having, so if you do have a 100 amp panel, you can make some electrification choices without having to upgrade your panel. There's ways to avoid it. And this kind of calls back to what we had mentioned in our previous workshops. It's really important to support these technologies that your home is properly air sealed and insulated. And if you have single pane windows, upgrading them to double pane or even triple pane will have a huge impact on your energy efficiency. Again, we talked about this a lot in our previous workshops with air source heat pumps. You want to make sure that you're getting equipment that is properly sized for your home and optimized for that space. Pretty low hanging fruit. If you don't have LEDs in your home, that's an easy way to save on electricity. Use, as we've talked about in workshop 2, in this workshop, getting into heat pumps and induction stoves. And then also just choosing power efficient versions of whatever appliances that you're using in your home. Another opportunity to sort of avoid having to upgrade your panel, we'll go through these quickly, is combining appliances. There's a lot of washer, dryer combos and oven and cooktop combos that will share a circuit. There's also circuit sharing devices and automatic pausing agents, which sort of function in the same way. This illustration shows a dryer and a EV vehicle charger sharing the same circuit. While the EV is charging, the dryer goes on, the EV charging will pause. Once the dryer is done, EV charging will go back on. And so they can share the same 240 volt circuit. You can combine small circuits into a sub panel. Again, a sub panel doesn't increase the capacity of your electrical panel. It just gives you additional spaces. And you can also use tandem or slim breakers, and essentially they're just more modern, up-to-date breakers that you can fit multiple into a single 240 volt slot. So these are some of the things you would want to ask contractors, or they should be able to answer these questions. You should be able to ask them, does my panel have capacity for this appliance or this particular equipment upgrade that I'm considering? What if I want to make additional upgrades in the future or add additional appliances? Will this panel be able to accommodate that electrical load? And how does the contractor assess your panel's capacity? And they should be doing the first 2 examples that we talked about earlier. You should never say that we're gonna assess your panel's capacity based on your home square footage or I've been doing this for 30 years and I kind of have a big idea of how much electricity you'll need and what size panel you'll need. So what are the costs and incentives? So for a panel, it can run from $1,000 to $6,000, and that has a variety of variables that go into it. With the wiring, if you need to retrofit wiring, it can be 800 to 1,500 per circuit. And again, circuit is just a wire that goes to your appliance. Time can vary quite a bit between weeks and months. It's kind of dependent, again, if you need to do additional wiring, if there's other additional service upgrades that you need, the availability of the electricians. And these are some of the incentives that mitigate those costs. We have the federal tax credit, $600, the federal rebate that is income dependent, and it's up to $4,000, which is a good chunk of that cost. And then again, these are some of the things that they're a little more uncertain, but up to $3,000 grant, availability not known currently. And then again, there's a federal rebate that's expected in 2025. And just to summarize, do I need to upgrade my existing panel? 60 amp, yes, more than likely. 100 amp, you need to kind of assess your panel and your energy load that you put that panel through. At full electrification, it might be worthwhile to upgrade that panel to a 200 amp, so you have that wiggle room to add additional electric appliances. If you're only going for partial electrification, you might be able to get by with a 100 amp panel. You just need to assess it and see what you're using.
So a sub panel, do you have 100 amp service? What does a sub panel do again?
It basically adds additional physical space, but not necessarily electrical capacity. So it gives you more breaker spaces. So if you have a 100 amp panel, I'm just throwing a number out there. If you have a 100 amp panel, you're only using 50% of it. You might be able to add additional breaker spaces, but you can never go above that 100 amps, regardless of how many spaces.
I never heard of shared, like how you
Mhm.
said your EV could be on the same, what is it, circuit or something as the dryer?
Mhm.
I wonder why electricians never tell you that, and neither do inspectors that come out. That said that when we got an EV, that we had to charge it less rapidly so that it could fit on the panel that we had.
Mhm.
And I thought, oh, you charge it at night,
Mhm.
do the dryer during the day.
Right.
I suppose you could have your oven on and your air conditioning all going at the same time,
Yeah, I mean,
but
some
not,
people. Some people do that. Appliances that aren't gonna be used at the same time, they can share a circuit,
but
switch off.
that is that.
And I'm interested, gonna get to our residential panel, and I imagine that they're gonna have some good input on that.
So,
So I'm happy to, go ahead.
we've had a couple of electricians in to talk about our panel and and if we need to upgrade it or not. And they've all said, it doesn't matter what you need or what you want. We have to think about the next buyer and what somebody else might, and so, like, what was with that?
Yeah.
We have to anticipate. So they're like, no, we can't use what you have. You're gonna have to, because of what somebody else, you might not use a dryer, or you might not use a what. But the next people that buy this place will, and they're gonna need more. And I'm like, well, that's their problem.
Right, it's going back to what you were saying earlier, it's like, I'm trying to create a home for myself, not necessarily this future person down the road that's gonna own it.
Let's
That's-
welcome up our president panel, and then we can
Yep.
continue with questions.
Well,
Yeah. So come on up.
yeah.
You like Johnny, we just talked earlier.
All right, so we're gonna welcome up Johnny Yukis and Mike Allen. These are residents that have gone through these upgrades in their homes themselves. And so they're here to talk a little bit about their journey and to answer all of your questions. we have about 15 minutes left, so we'll probably go a little bit past 7:30. If we need to head out at 7:30, feel free. But we'll certainly be here to answer your questions. So just quick, introduce yourself and tell us a little bit about your electrification journey, specifically kind of focusing on the appliances that we talked about here tonight.
I'm Johnny Ukas. So I started something called Rochester Electrified for helping with stuff like this. And so our family has done full electrification for our vehicles, our house, everything. And I've seen some faces from last one too, where talking about contractors definitely ran into many of the same things where they tell you what you can and can't do and all that type of stuff. And you kind of have to push through that. So I feel your pain.
I'm Mike Allen. I'm actually a building contractor, but I've taken an older farmhouse and done a complete retrofit with that. So we converted it completely to about 90% of electric on that. So done quite a bit of remodeling and things like that as well. So I've heard similar stories like that, which you've had as well.
I think for the sake of time, we'll open it up to questions. I forgot the question from earlier already, but do we want to start there? Your question from earlier, was it about heat pump water heater sizing? Everyone's telling me that I need to go larger, but we feel like we can get away with a smaller size, so.
It's kind of like with the panels, I mean, they're like, no, you have to go, like, you know, the next people that buy this place, they're gonna want a bigger water heater than you are. And I'm like, well, good for them, but I shouldn't have to, I mean, and you say to just push through it, but you know, we've had 3 out there and they all keep saying, oh, and I'm like, is there some kind of city code that's requiring this, or they're just being, like, they're being?
So I can talk about my experience for the heat pump water heater. So we are a family of 4. We have 2 smaller kids right now, so they're not teenage where they're gonna be using more waters for showers. So we have a 50-gallon, I believe, heat pump water heater, and it works fantastic for our family. And I would say part of that too is we also use RPU's time of use. And so one thing that's kind of nice, we have a Rheem hybrid water heater. We can schedule, when it's running. So a lot of times what I'll do is I will have it basically start right before, or not right before, but kind of before my wife and I might be taking showers in the morning. So it's just ready. Then during the time that it's more expensive, it turns off, and then as soon as it's off peak again, then it turns on. And we do have, so they talked about the 120 volt ones where, in my experience, we've been able to do just the heat pump probably like 98% of the time, and then every once in a while that 2%, we have needed just a little bit more hot water than what's typical for us. So we did end up going with the 240 volt option, so that 2% of the time, we could have just waited longer for it to come back, but we're like, we want the ability to have hot water faster if we want to, and I can make that switch from an app, and so it was, I find that pretty handy.
Right, but same, you can do 50 gallons gonna cover you most of the time. You should have no problem. Now, I do not have the younger children, I've got the older ones. So I've got the ones that will take a way too long to shower. That being said, I've got an A.O. Smith system, and I've actually got mine on what they call hybrid. So it will run just super efficient all the time, and I've yet to really have a problem. Like if everybody's just gonna take showers to save time, depending on your household, yes, you're gonna drain that 50-gallon unit out. It's not gonna be able to keep up. The Rheem is fantastic. That's another unit that does really well. Efficiency wise, you should be fine But depending on your household wise, that 50-gallon unit. I can't believe you're gonna have that issue. Unless it's really under high demand with multiple things happening at the same time.
Other questions from the group, anything about water heaters, induction, cooking, electric panels? Need to know when to upgrade. I guess I'm interested in, as you went through this journey, what were some of the challenges that you ran into and kind of how did you work your way through those different challenges and upgrading these different appliances in your home?
I think the main challenge is just what you guys are speaking of. The technology is going so fast. We didn't have washer dryer combos like this a handful of years ago, running off 120 volts. We just didn't have them. We don't have car chargers, when they first came out that were running off of 120. It's getting the trades people to accept the fact that the technology is there. I think that is going to be everyone's largest hurdle to cross. Is the fact of, nope, it's there. GE Profiles washer dryer combo works fantastic. Its capacity is just as large as most units right now. And we're doing a family of 4, no problem with that. And that's off of the 120. Not ducted to the exterior. So it is simply just crossing the hurdle of the contractor saying, I've been doing this for 30 years. This doesn't work. No, it does work. The technology is just moving quite a bit faster than I've ever seen.
Yeah, so the same thing for me, it was always the contractors that were the barrier. Luckily, I have a couple of friends that have a bit of an engineering background, and so, the contractors say, no, you can't do this, and I say, well, why? I see stories that this is done in a similar climate, why can't it be done here? And so, some of the engineering friends would say, it can be done, and here's the math behind why it can be done, and they may be grumpy about it, but if you say, this is what I want, I know it's possible, here's my money, are you the one to take it and do it?
Yeah.
And honestly, that was the point I had to get to for contracts to be like, yeah, okay. The second problem I ran into is because it's so new, and there's a lag of that knowledge, for a lot of our systems, the installers were getting out the manual and learning about it the first time as they were installing ours. And, and we had to have them come back, for our home heat pump, they had to come back twice. But eventually they got all the kinks worked and it was working fine. So, I would say it is definitely going to be pushing through that. And when we got a lot of this stuff installed, it was about 2-3 years ago. So there are certain companies that have more experience and they're even focusing on it and doing the training around it too. So that's a great, the questions that they brought up for like, what to ask. That's another great thing to say. What is your experience with this and what kind of training? There's some contractors that I talk with and, they're on top of it. So it's coming around slowly. It's not across the board for everybody. But it is kind of just about finding the right one, and it's definitely possible.
Yep, question in the back.
I know in some places in the world, they use on-demand water. How does that compare with tanks and, in terms of efficiency and cost all over?
Just to repeat the question, around on-demand water heating and how that compares to what we're talking about here today.
So on-demand units, they're fantastic. It goes to a supply issues to a certain degree, and you can do different combinations with them. Like you can have multiple in a home. smaller units, large units, things like that. There again, you're gonna run into exactly what Johnny's talking about, is that uphill climb of who do I get to? You're all gonna have to be patient with contractors, that for certain. That's a nice way for me to phrase that. Who's going to do that project? They work fine, I've seen them work, but it does have a difficult time from a longevity perspective of keeping up. It is nice, and that's where, especially now with the systems that we have now, like your A.O. Smiths and your Reams that have that tank capacity, it does come in handy. And it really does, because that on-demand, you gotta imagine that coil system, it's firing very hot and it will wear out. It just won't be able to keep up over a longer period.
Cost wise? Otherwise?
Cost wise, from a standpoint of running it, that I can answer to that.
Yeah, I mean, you can kind of see it in the cost difference, that 2% of the year that we basically return on the rod. In our water heater, and it does become much more expensive. But part of the reason for that is just because the heat pump is so efficient that it's really inexpensive. So, like you said, it's fast and so I also don't really know the exact cost difference, but, versus a what's that? Usage, yeah.
Usage would play such a role, because again, it's a lot of power and that coil system has to stay so hot, so there's so many factors here for all of you that you're gonna depend on how your family uses the home.
Yes, right here in the front.
Got a couple of questions. What's the difference between a water or a heat pump? Without a tank and one with a tank? And what's the cost? What if you have a 60 amp wall box without breakers? What's the approximate value? Do you recommend going to 100 watt, 100 amp, I mean, on the wall, or do you recommend if you got enough power there for your fuses to stay with the fuses? And there's another question too, but let's give some answers.
So the first question was around, tankless versus,
Understand you, sir. Probably not gonna help you on 50 over here, but can he enough? Can you?
do you wanna take it down?
Yeah, I can jump in. So the question was, if you have a 60 amp panel, would it make sense to upgrade to a 100 amp panel?
Yeah,
If you're gonna upgrade your panel, we'd recommend just go straight to 200.
I'll go to 200.
Yeah, if you're like getting someone in and make that upgrade, just get as much capacity as you can.
You'd have to upgrade to 200, and can you stay with 60?
You certainly can if that like fits in with your plan, like Jason was describing. But if you are gonna pay for a panel upgrade,
There's no real problem if I know with this, with the fuses, do I have to stay with? Do I have to go to a circuit breaker? I know it's a dynamic, but if I stay with the fuses?
yeah, let's talk after. We can talk about your specific situation. Yeah.
Okay.
I know they kind of have storm here, that's what I care about.
Are you asking like the twisted style fuses? Yeah, once you do your upgrade, you're gonna have to go to a breaker style. Yep, that's
What upgrade are you talking about?
the electrical panel. If you have the old
Yeah, that's-
screw-in style, fuses per se.
What if I don't go to an upgrade?
Yep, what's that?
What if I don't go to an upgrade?
That just stays what you have.
I mean.
But if you upgrade to-
Go with fuses.
Yep, if you upgrade to even whatever amperage, now it has to go to today's building codes. And the electrical code is federal, so you're gonna have today's breaker system.
So if I upgrade to, are you recommending, like you said, 200 amp instead of 100?
My set, yeah, 100%. I would agree with that.
Okay, thank you.
And just one thing to add to that, so when we were doing our transition from everything from gas to electric, I basically told every contractor that from the get-go. And we did go from 100 amp to 200. We potentially could have done some of like the smart switch stuff, and maybe gone to 150, but we just made that decision, right at the beginning to just make the jump, up because it is a big expense and you only want to have to do it once. So just do it all at once.
So I have another question. What's the difference between the tankless water heater and a one with the tank? What's the difference as far as how do you compare the one with the tankless? With the tank.
Yeah, they're pretty different technologies. So one is heating up a tank of water and the other just is a box that heats it up instantaneously.
And I got a friend that's got a tanks. And I know a little about it, so that's what I was wondering about that. And I could put a different water heater in if I would, and I don't know how I would compare one with the other, tank one with the tank.
Well, yeah, let's chat after, yeah.
We're gonna take one more right here and then we're gonna break. And if you have other questions for our panelists or for Matthew and his team over there, feel free to talk to anyone afterwards. So last question right here.
So the resident panel, you went to on 200. Does that handle everything, including your electronic vehicles? Or did you have to put in yet another panel?
So we have a sub panel for our garage, because we have a detached garage, so, but otherwise that's our complete, electrical capacity, that covers everything. And so it's even a little bit more than we needed technically, but if we add any other appliances or, whatever, we've got room for it, and that was kind of the plan, so. So yeah, we, that covers everything, but like they said, what the technology was there for the smart switch stuff when we were doing it. None of the contractors really were doing anything with it. There's smart panels, smart switches, there's a lot of things happening right now. That offers, more things you can do with your specific situation. It's just a matter of, does the contractor already know how to do it, or can you talk them into it? So that's probably what you're running into.
Yeah. Yeah, agreed. A 200 amp panel typically will do just about anything you need. I mean, honestly, there is the smart panel, that's a complete breaker system that actually is a smart panel altogether that will transfer everything and track everything. But 200 amps is actually a lot of power when you really break it down. It covers all one. Especially again, the technology is moving so quickly that, and just utilizing your space correctly, charging at night on your car, so you don't need that full, heavy duty charger, things like that, just small little, utilizing the space in an efficient manner. 200 amps is gonna do most people's homes.
And they also said, this is if you turn everything on at the exact same time.
And
We've
Brian,
never done that, so it's just, it's a safety thing as well.
All right, thank you. Well, can we get a round of applause for our resident? Thanks. All righty, and I think we're just wrapping up. I think we have one more slide. Great, have one more slide?
Yeah. Yeah, just want to give a big thank you to everyone who participated in our workshops. We hope you learned a lot. We hope you'll fill out the survey in front of you to let us know how we can improve. We have a number of resources that you'll get in your email to help you take next steps. And then there are a number of events coming up for sustainability, so there's always a way to keep helping our earth here in the Rochester community and beyond. So thank you all so much. Have a great night.
Thank you.
Thank you.
Oh, yeah, that's the other one.